Welcome to Learning Path 3, Design and Implement a Release Strategy. In this path, you'll discover how to build and manage release pipelines using Azure DevOps. We'll explore best practices for automating deployment, setting up environments, and ensuring your releases are reliable and secure. Throughout this journey, you'll learn how to create pipelines, apply recommendations, provision and test environments, and modularize your tasks. We'll also cover advanced topics like multi-stage YAML, health automation, and effective use of release gates. By the end, you'll be equipped to streamline your release process and deliver value with confidence. In this video, we will explore how to create and manage release pipelines in Azure DevOps, so let's jump right in. Release pipelines in Azure DevOps are essential for automating the deployment process across multiple environments. They allow teams to deliver applications consistently and reliably, and reduce manual errors and speed up delivery. Azure DevOps supports YAML and a graphic user interface known as the classic release pipelines. A release pipeline consists of stages, each representing an environment such as a deployment or testing or development or production environments, and these stages can define the sequence of deployments and the conditions under which they occur. Stages can include approvals, gates, automated tasks, providing flexibility over the control of the deployment process. This ensures that only validated changes progress through the pipeline. Artifacts are the building blocks of a release pipeline. They represent the output of the build process, such as compiled code or configuration files, and serve as the input for the deployments. So managing artifacts effectively ensures that the correct version of the application is deployed to each environment. Azure DevOps integrates with multiple artifact sources, such as build artifacts, the repository itself, Azure artifacts, and external repositories. Choosing the right artifact source is crucial for ensuring that your software deployments are reliable and traceable. Artifact sources such as build artifacts, package repositories, container repositories, and source control are the origins of the files and packages that get deployed through our pipeline. By selecting an appropriate source, you gain traceability and auditability, meaning we can always go back and track where our code came from and who made the changes. This is essential for compliance and troubleshooting, as every deployment can be traced back to its origin, making it easier to identify and resolve issues. Versioning. Immutability ensures that once an artifact is created, it cannot be changed, which protects the integrity of our releases. So versioning allows us to deploy specific versions of our application or roll back to a previous version if needed, and maintain a clear history of these changes. These practices help teams deliver updates confidently, knowing that each release is consistent and secure. In summary, the artifact sources are the backbone of a robust release pipeline, supporting reliability, auditability, and maintainable software delivery. When planning deployments in a release pipeline, it's important to consider several practical questions that shape our strategy. For example, do you need to deploy every day? Or is your target environment used by just one team or multiple teams? Understanding who the users are and how often they want new versions helps us decide how frequently to release the updates. You'll also want to think about how long deployments take, whether there's any downtime, and what impact they might have on the performance and the user experience. These considerations ensure that your deployment process is efficient and minimizes disruptions for everyone involved. By asking these questions up front, you can design a release strategy that fits your organization's needs. For instance, if your users expect frequent updates, you might automate daily deployments. If downtime is a concern, you'll want to plan for maintenance windows or use deployment techniques that reduce interruptions. Considering the target environment, whether it's for a single team or shared across many, also helps us tailor an approach for scalability and reliability. So ultimately, thoughtful deployment planning leads to smoother releases, happier users, and a more resilient software delivery process. Deployment stages are essential for organizing and controlling how software moves from development to production. A stage is a logical boundary within the pipeline that contains one or more jobs, and different release tools may refer to these as stages or environments. Each stage represents a distinct environment, such as development, testing, or production, where specific tasks are performed to validate as we deploy our application. By clearly defining stages, we can manage long-lived environments like in production and short-lived ones such as feature testing. ensuring that every change is properly vetted before reaching the users. The purpose of each environment within a stage is to support different goals. So releasing new features, fixing bugs, for example. A feature release might be deployed to a test environment for validation before moving to production. This structured approach helps teams maintain high quality and reliability, as issues can be caught early and deployments can be tailored to the needs of different user groups. Ultimately, deployment stages make it easier to coordinate releases, minimize risk, and deliver updates efficiently. In Azure DevOps, build and release tasks are the building blocks that automate the steps needed to compile, test, package, and deploy our applications. Think of each task as a unit of executable code that performs a specific action, like running a test, uploading files, or deploying to a server. These tasks are organized in a sequence, ensuring that each step happens in the right order for a smooth and reliable release process. The system is highly extensible, allowing us to add tasks from a marketplace so we can customize our pipeline to fit our project's unique needs. The real power of build and release tasks come from the flexibility and the community support. So we can choose from a wide variety of tasks, such as extracting files, installing certificates, or publishing releases, making it easier to automate even complex workflows. Custom build and release tasks in Azure DevOps give us more flexibility to automate specialized deployment steps that aren't covered by the standard tasks. These tasks can be made private for internal use or shared publicly across organizations, allowing us to access variables and secure endpoints that might otherwise be restricted. By leveraging custom tasks, we can safely and efficiently distribute deployment logic and ensure sensitive details like credentials or implementation specifics are hidden from users who don't need to see them. This approach streamlines complex deployments and helps maintain security and consistency across projects. Custom tasks have the ability to scale across our organization. Once a secure endpoint or deployment process is defined, it can be reused by multiple teams without exposing the underlying details. This reduces the risk of errors and saving valuable time. The Azure DevOps Marketplace offers a wide range of community-contributed tasks, so we're not limited to what's built in. If we need specific integration or automation, chances are someone has already created it. In Azure DevOps, a release job is a sequence of tasks run one after another on the same target machine, orchestrating the automation for that deployment process. So think of a release job as a checklist. Each task is a step, and the job ensures the step is completed in order, whether you're deploying a web app, updating a database, or running tests. Release jobs can be combined with a single pipeline, enabling multi-platform deployments. For example, you might deploy a .NET backend on Windows, an iOS app on a Mac OS, and an Angular frontend on Linux, all coordinated through jobs that run on the appropriate host machines where the agents are installed. Let's talk about deploying a database. So deploying a database as part of our release pipeline requires careful planning and the right tools to ensure data integrity, security, and reliability. Key provisions include separating data for different environments, preserving existing data during updates, and using idempotent operations so deployments can be safely repeated without causing errors. Implementation tasks range from creating deployment scripts and securely storing connection strings to configuring dependencies and including database testing steps. Azure DevOps offers built-in tasks and supports third-party extensions, while specialized tools like SQL Server Data Tools, SQL Package Executable, and Azure CLI and SQL Server Management Studio also help automate and validate database deployments. Monitoring and alerting are also essential, with mechanisms for rollback and recovery using frameworks like Entity Framework. Automating database deployment in a CI/CD pipeline brings significant benefits. By leveraging custom scripts, such as PowerShell, Bash, or SQL scripts, teams can streamline repetitive tasks, reduce manual errors, and ensure consistent deployment across environments. Automation supports versioning and rollback, making it easier to revert changes if issues arise. And testing and validation steps help catch problems early, while monitoring and alerting keep teams informed about the health of our databases. Ultimately, these practices enable faster, safer releases and empower organizations to maintain high standards of quality and reliability in their software delivery process. This concludes our session, and there are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.